Okay, let's get through this review really fast, I hope. All right. Oh, I'm going to hide that. Don't mind that. Okay, there. Okay, so the vertex of the graph of the quadratic function. Everybody knows the formula to find the vertex. First of all, you're going to find the line of symmetry. And to find the line of symmetry, you're going to use x equals negative b divided by 2a. B is 24. A is 3. So I'm going to have negative 24 over 2 times 3, which is negative 24 over 6, which is negative 4. So that's my x value. I go back to my equation and I substitute negative 4 in for x. So I end up with y equals 3 times negative 4 squared plus 24 times negative 4 plus 48. And I'm going to put that whole thing in my calculator exactly like it is. And when I hit enter, it's going to give me a 0. So my vertex is going to be negative 4, 0, which happens to be the root. Just a lucky thing. Okay, number 2, we're going to use the calculator, which I have my calculator out here somewhere. I'm going to go to Stat, Edit. I'm going to go to L1, and I'm going to put in all my x values. Negative 2, enter. Negative 1, 0, 1, and 2. I'm going to go over to L2, and I'm going to put in 6, 4, 0, 1. Oh, no, I'm not. I'm putting in the wrong one. 6, 4, 0, negative 6. Start putting in the wrong ones, and negative 14. Okay, so now that I've done that, I'm going to go to Stat, Calc. We're doing quadratic regression, which is number 5. Enter. I got L1 and L2. I don't need to store it because I'm just going to write down my answer. When I hit enter for calculate, I'm going to get a equals negative 1. So y equals negative 1 x squared minus 5x plus 0. And that's my answer. So I'm going to go back to my test, or my review, whatever that is. And I'm going to write y equals negative 1 x squared minus 5x. I'm not going to put the plus 0 because I don't need it. And I'm done. If I'm looking for the roots are always, always, always where it crosses the x-axis. So the roots are negative 1 and positive 4. So not this one, but these two are the roots, which makes my answer C. That was almost too easy. Number 4. When I'm doing a graphical representation of the ball being tossed in the air, basically it's going up and then coming back down. So I'm going to have 2 roots, one at 0, 0, because that's where we start, and one at whatever time the ball hits the ground. So this is my time. And when I get back to y equals 0, that's where I'm going to have how long the ball was in the air. So basically, h is equal to 0. So I have negative 16t squared plus 72t equals 0, because I want where the height is 0, where the ball's on the ground. I have a common, greatest common factor, and it's got a t, and I think it's probably negative 8. You could do 8. Negative 8 just moves my minus sign to where I want it. So if I divide through by negative 8t, I end up with 2t minus 9. So my new equation looks like this. So either negative 8t equals 0 or 2t minus 9 equals 0. Well, negative 8t equal to 0 is t equals 0, which is where the ball starts, and that's not what I'm interested in. 2t minus 9 equals 0. I'm going to have 2t equals 9 divided by 2, and t equals 4.5. So B is the correct answer. Number 5. I'm looking for the vertex, which is right here. And I'm looking for the axis of, or line of symmetry or axis of symmetry, which is right there. So my axis of symmetry is -2. So A and B are wrong. And notice the trick, because they both have the same vertex. One has x equal and one has y equal. My vertex, my line of symmetry is always x equals. So D is the correct answer. Okay, axis of symmetry, line of symmetry. The formula we used in number 1 is x equals -b over 2 times a. In this equation, a equals 2, b equals -3, c equals 7. X is equal to -3, which is 3, over 2 times 2, which is 4. So it's a positive 3/4, and it's x, not y. So A is the correct answer. Okay, simplifying a square root. I'm not going to worry about the 2 right now, and I'm going to find all my factors of 108. And I'm going to stop when I find perfect squares, because I know when I square root them, I can just put that outside. So I'm not going to go all the way down to my prime numbers. But I think that since 4 goes into 8, I can divide by 4. My factors are 4 times 27. There's a perfect square. I'm leaving it. 27 is 9 times 3, another perfect square. So if I rewrite this, I have 2 times the square root of 4 times 9 times 3. And I'm going to square root my 4 and my 9 and take them out. So I have 2 times square root of 4 is 2. Square root of 9 is 3. And my other 3 stays inside the square root sign because it doesn't have a perfect square. It's not a perfect square. 2 times 2 times 3 is 4 times 3, which is 12. So my answer is going to be 12 times the square root of 3. Using that strategy, we're going to solve number 8 using our quadratic formula, which is on your math chart, but it is x equals -b plus or minus square root b squared minus 4ac over 2a. Okay, I need to solve for, set this equal to 0, so I'm going to have 3x squared minus 7x plus 3 equals 0. A is 3, B is -7, C is 3. So I end up with x equals -b, so it's a negative, so it's 7 plus or minus the square root of 49 minus 4 times 3 times 3, all divided by 2 times 3. So I end up with 7 plus or minus the square root of 49 minus 36 over 6. 49 minus 36 is 13, so it's not A or B. They separated out their plus and their minus. So the only other thing that's different is the leading 7 is negative or positive. And since it started out as a negative number, we took the opposite. So C is the correct answer. Okay, discriminant review. The discriminant is the part of the quadratic formula that's underneath the radical sign. So the discriminant is b squared minus 4ac. So, but I don't even need to use that because it already told me if there's no real solutions, then my discriminant needs to be negative. We talked about this. If the discriminant is positive, then you have two solutions. If the discriminant is 0, then you have one solution. And if the discriminant is negative, you have no real solutions. So if there are in fact no real solutions, then my discriminant has to be negative. Okay, this is one of those two steps. Not only do we have to find the roots, but we have to find the product of the roots. So when I'm all done, I need to make sure I multiply my roots together. I think I shall use my calculator. I'm going to clear all that out. Oh no, guess I'm not. Okay, I'm going to clear all that out. I'm going to go to y equals. For y1, I'm putting in 12x squared plus x minus 6. And y2, I'm putting in 0. So that when I graph, I need to change my window. So I'm going to change it to zoom 6 so I can see the whole thing. Okay, there's my parabola. The red line is my y equals 0. I'm looking for the intersection. So I do second, trace 5, enter, enter, enter. So my first intersection is 0.666667, which I know is x equals 2/3. I'm going to write it as a fraction because I don't like that decimal that repeats and goes on forever. My other root is going to be second, trace 5. Now I'm going to move my blinky thing. I move it using my arrow, so it's somewhere closer to this. And then I hit enter, 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 and I end up with negative 3/4. So I have positive 2/3 and negative 3/4. So I have x equals 2/3, x equals negative 3/4. I'm finding the product. So I have 2/3 times negative 3/4. I multiply straight across. Ooh, or I can just cancel out my 3's. And I end up with 2/4, which is negative 1/2. So negative 1/2 is the product of the roots. Okay, number 11. I'm going to set equal to 0. So I have 4x squared minus 8 minus 276. I'm going to combine my negative 8 and my negative 276. So I have 4x squared minus 284. I'm going to divide by 4. So I have x squared minus 71. And I know that that is not the difference of two squares because 71 is not a perfect square, but I am going to need the positive and negative of the square root of 71. So, okay, I'm going to do a little trick. See if you follow along. I'm going to square root my x, and I know that I have a plus and a minus, and I'm going to square root my 71, which is the square root of 71. So actually I have x equals the square root of 71 and this negative square root of 71. So write it over here. X equals the square root of 71, positive or negative. So if I put the square root of 71 in my calculator, I get 8.42. So x is negative 8.42 and x is positive 8.42. So those are my two answers, although if it doesn't specify, I could leave it as a square root sign. Okay, number 12. Oh man, I'm not even close to done. I don't think I can pause. All right, let's see if we can get through this. I don't think I have that many more. Yeah, I kind of do. Okay, when I look at the formula this way, there's two things I notice. First of all, there's the -2 in front. That means that it's frowny. So I can eliminate A and D. I also know that my vertex is 1, 1. It's not -1, remember, because we talked about that negative stays with the equation. So actually the number 1 is a positive, not a negative, which makes my answer C. I'm going to go ahead and put it in my calculator and double check that that's actually the truth. So I'm going to put, and I can put it in just like it is. So I can put in -2, parenthesis, x minus 1, parenthesis, squared, plus 1. And I already have my 0, so I can graph it. Oh, look at that, it is C. How about that? Wow. Yeah, we're awesome. Okay. And then we're going to change our pen color. You don't have to, but you usually do what I do, right? And since it's March, we're thinking about St. Patrick's Day. And if it really is St. Patrick's Day, I guess I should do a 4-leaf clover. I don't know how to do a 4-leaf clover. It ends up looking like a flower. Okay, there's my 4-leaf clover. What a lucky thing that is. All right, back to business. Okay, 13. Okay, this one's a little tricky also because we're looking for the time when the baseball is 40 feet or more above the ground. So here's my 40. We want to know how long it is from here to here when the baseball is higher than 40 feet. So I'm starting at 0.5 and I'm going to 2, which is 1.5 seconds. How much time did you spend on that? Because that was so easy. Okay, 14. The solution set appears to be in between 5 and 10 and in between 15 and 20. There are 2 of them. Neither one are negative. So our answer should be C. Again, too easy, too easy. All right, let's see where we are. We're on the last page. Okay. I'm again using my quadratic equation. A equals -5, B equals -9, C equals 3. So I end up with x equals -9 plus or minus the square root of 9 squared, which is 81, minus 4 times -5 times 3 divided by 2 times -5. So we have 9 plus or minus, notice 9 is positive, square root of 81, and ends up being plus because I have -4 and then a negative. 20 times 3, which is 60, divided by -10. Oh, there's a negative sign. 81 plus 60 is 141. 141 is 3 times 7, which is nothing. So I have 9 plus or minus square root of 141 over -10. 141 has the factors of 3 and 47. 47 is prime, so it doesn't factor. So I'm leaving it as 141. Boom. And what they did in C was, which is the answer, all they did was they took that negative 10 and they put it over the 9, and then they put it over the square root, which is the exact same thing as having it all together in the numerator. So that one is done. Okay, consecutive integers. If there's consecutive odd integers, that means one of them is x, and one of them is x plus 2. And if I multiply them, I end up with 99. So I'm going to multiply them out, x squared plus 2x. I'm moving my 99 over here, so it's minus 99 equals 0. I'm going to put that in my calculator, because I can. Wahaha. I'm going to clear it out. I'm putting in x squared plus 2x minus 99 graph. Wow, it's really big. So I'm going to do zoom 3, enter. See if I can get the whole graph. Ah, there it is. All right, second, trace 5, enter, enter, enter. So one intersection's at 9, which means my numbers are going to be 9 and 11 because those are consecutive integers. And if I multiply 9 times 11, that's 99. Got it. And there's another one though. Second, trace 5. Where'd my blinky thing go? Come on. Oh, there it is. Enter, enter, enter. So I also have an intersection at negative 11, which the next consecutive odd integer would be negative 9. And negative 9 times negative 11 also equals 99. So there actually are two answers. Okay, so we have for the roots x equals 9. So we have 9 and 11. And then we have x equals negative 11. So we have negative 11 and negative 9. And yeah, if I were giving a test and you didn't put both of those sets of numbers, I'd probably take points off because there actually are two sets of integers. Get it? Okay, number 12, really easy. We can just look at the differences. The first one, these are going down by 1, so it's minus 1, minus 1. These are going down by minus 4, right? Okay, so that makes it linear. The next one, they're going down by 1s and my x values, or they're going up by 1s, and my y values are going down by 9, 7, 5. Okay, not linear. And if I did my second difference, I'd end up with 2, negative 2, negative 2, actually positive 2, which makes it quadratic. The other thing we could do is we could put them in our stat edit and look at the graphs and just see if they made a straight line or a curve. Those would be the two things I would try first. So there you have it. Good luck.